What kind of equation do you think we call this? Why? Because it's got a radical in it, and we're trying to find x. Exactly. Okay. Do you remember how to solve these? We have to get x by itself. Square both sides to get rid of the square root. What does the equation look like? Therefore, x equals? Do you remember what else we had to do with these ones? No. We had to check them. Oh, come on. Really? This is how much you have to do. Is the square root of 7 plus 2 equal to 3? Yes, the 3 equals 3. We're done. That's all a check requires.
I don't get it.
So this is grade 11.
It's a lot of people that
This is grade 11. In grade 11, we also solve quadratic equations using graphs. We can solve radical equations the same way. Do you remember how we solve an equation using a graph?
really distracting me.
Anyway. How we solve by graphing is we graph each side of the equation. So what we're going to do is we're going to put a y equals in front of each side of the equation. And we're going to graph each of these. Well, let's graph y equals 3 first. What does the graph of y equals 3 look like?
Go up 3. And then it's 1 on 1 up. Oh, yes,
Why?
I don't get it.
Why?
Because you go up to 3.
That's I remember I got wrong with this last year.
Okay, that's y equals 3.
Explain to me why.
It is a horizontal line. Listen to her. That's what she's saying. She's saying what she's saying is correct. Horizontal line through y equals 3.
I get it now. Thanks, Gina, for explaining.
This one. How do I graph y equals root x plus 2? How do I graph y equals root x?
Is it that?
0, 0, 1, 1, 4, 2. But this tells me to do what to it? It's y equals root x 2 to the left. So 0, 0 goes 2 to the left. 1, 1 goes 2 to the left. 4, 2 goes 2 to the left. The next one I could actually do is 9, 3. Or sorry, 9, 3. Which would be way out here. 9, 3 would be out here, and then I go 2 to the left. So 2 to the left. 9, 3 would be out here, and then I go 2 to the left. So that would be actually a third point. Like, both of you are gonna go out if I hear it one more time. I don't care who it is, but both of you are gonna go if I hear one more yawn. I'm saying, I don't know who did, but both of you will go if I hear it one more time. It's incredibly insulting. And I don't see, and clearly you don't care because you just keep doing it. And I'm not talking to anybody in particular, but when I turned around, you guys were blaming each other, and you guys were saying it was her, and you're saying it was her. So I'm not gonna worry about finding out the truth. I'm just gonna take the two of you. Because I figure I've got somebody. Jeez. I just can't believe how you can't look at that and say, man, that's really insulting towards him. Where do they cross? Where do they intersect each other? Right. Or where x is 7. What do you notice when we solved it algebraically?
X equaled 7.
X equals 7. So how do you solve graphically? You graph each side of the equation by putting a y equals in front, find where they intersect, and read the x coordinates, because that's what we're solving for, is x. Okay? So the next one. Don't worry, I'll go back to that talk later. Here's another one. Let's solve this one algebraically. You guys should know what to do here. What's the first thing I do? Get the 4 over. Get the radical by itself. So subtract 4 from both sides, and you get this. Now what? Square both sides. And you get x minus 3 is equal to positive 4. Therefore, x equals something's wrong. No, nothing's wrong. Yeah, that's right. X equals 7, right? Check. What happens? What happens? That was weird. Okay, I guess I gotta do it again.
You were on example 3.
I was doing example 3. Shoot. Okay, let's continue doing it. See if I can bring it back. There we go. X equals 7, so I'll do 3 first. Doesn't really matter what order they're going. Now I gotta check. Does the square root of 7 minus 3 plus 4 work out to 2? What is the square root of 7 minus 3? 2 plus 4 gives me 6 on the left. No, that does not equal 2. Therefore, what's the solution?
No.
There is none. No solution. So, what do you think that means if I graph both sides and look for where they intersect? They won't touch. They can't because there's no solution. And let's verify that. So let's graph y equals x minus 3, square root x minus 3 plus 4. And let's graph y equals 2. Well, let's graph the y equals 2 first, because that's the easier one. Go up to y equals 2, horizontal line. For this one, what do? I take all my points, my reference points, and do what to them? Move them. Sorry? How much? 3 to the right and 4 up. So 0, 0 goes here, here. 1, 1 goes here, here. 4, 2 goes here, here. And that's y equals root x minus 3.
So when do you pick the fourth one?
Well, I had to pick the fourth point in the last one to see where they intersected. Here, I don't have to worry about it because they're never going to intersect.
But what happens if you didn't agree and they didn't intersect? Then you'd be wrong.
Match your algebra with your graphic. Like to me, this tells me, just like Shane said, this tells me they're not going to intersect. And this confirms it. Okay. This previous one tells me that they're going to intersect. Okay, and they're going to intersect out when x is 7. So they're going to intersect way out here, so I need an additional point. Okay, is that better? So here, no intersection, no solution, because they don't intersect. Okay, the last one, which is actually the second example. So let's do it algebraically. What's the first thing we're going to do? Move the minus 3 over to this. Get the square root by itself before you square. Square both sides. Well, the square and square root cancel each other out here, so I'm left with x plus 3. What's x plus 3 all squared? It's x plus 3 times x plus 3, which means 4 multiplications, which gives me x squared plus 3x plus 3x plus 9. What kind of an equation do I have? Quadratic, and I also have an x term, which means I have to solve by factoring. So I have to get everything over to one side, factor, and find my solutions. So I need to toss the, so here, I can simplify the right by combining the 3 x's. When I move the x over here and the 3 over here, it's going to be 0 equals x squared plus 5x plus, hang on. So you get 0 equals x squared plus 5x plus 6. Now you got to factor. I know you're factoring. We got plus 2 plus 3 or plus 3 plus 2. Therefore, what are my solutions for x?
-2 and -3.
Because remember, you gotta set each factor equal to 0 and solve. So x plus 3 equals 0, therefore one answer is x equals -3. X plus 2 equals 0, therefore another answer is x equals -2.
And we have to check them. So this is a fair amount of work involved doing this algebraically.
So the check, we're gonna check both of them. And remember, checking the original, not any that you've changed. So does the square root of -3 plus 3 minus 3 equal -3? Well, -3 plus 3, square root of 0, minus 3 gives me -3. That's good. -3 is a good solution. Does the square root of -2 plus 3 minus 3 equal -2?
It will.
Because this is 1 minus 3, which is -2, and yes, that does equal -2. So they're both good.
So that means when I graph both sides and look for the intersection, how many am I going to find? 2. So that gives you a hint on how your graph should look like.
So to graph it, we're going to graph the left side by tossing a y in front of it. And we're going to graph the right side by tossing a y in front of it.
And hopefully we're going to see those 2 points of intersection.
For this one,
Oh, you guys should know.
I'm going to take every point and do what?
3 left.
3 left, 3 down. So 0, 0 goes 3 left, 3 down. 1, 1 goes 3 left, 3 down. Wait. I'm going up. 3 left, 3 down. 3 left, 3 down. 4, 2 goes 3 left, 3 down. So it's going to look like that.
What does y equals x look like? Yeah. Think about a table of values. If x is 0, what's y?
0.
If x is 1, what's y? So all the points are going to be like 0, 0, 1, 1, 2, 3, -1, -1, -2, -2.
So they're going to look like this. 0, 0, 1, 1, -1, -1. And I'm going to draw it like that.
And I can see that it intersects at 2 spots.
Here where x is -2, and here where x is -3. So I confirm. Okay. Questions?
Always a diagonal line, always. Okay. Yeah. So to conclude, just to go back to this, how do we solve graphically?
We solve graphically by graphing each side of the equation
By just putting a y equals
the x coordinates coordinates of the intersection point or points if there are any, because we saw cases where there were two, we saw cases where there was one intersection point, and we saw a case where there was none, will be the solutions. To the equation. Just like we did last year with quadratics. Graph each side by tossing a y equals in front. Look for the point or points of intersection if there are any. Find the x coordinates, those will be your solutions. Okay.